ago. She is our moderator and a marketing specialist for hazard control technology. So today we're going to be talking about sprinkler and deluge system solutions involving F500. And what we'd like to see is uh, you all be able to ask questions freely. We would love it if you would put those questions in the chat. Also, we would love it if you would silence your phones and stay muted uh, until we get towards the question and answer session, which we will have at the end. And also, um, uh, we would love to see you put in chat your name, your organization that you're representing today, your role in that organization. And what I would really like to see is just a really short sentence or statement about why you're interested in F500 proportioning into your sprinkler or deluge system um, or systems, what your concern is, what your industry is, why you've joined us today. So again, welcome everyone. We're going to go ahead and get started with the content of the webinar. And please put your questions in chat so that we don't forget to get them answered. And as always, you can join us via phone call later or submit requests for information via our website as well. So welcome again, and we'll go ahead and get started here. Hazard Control Technologies has been in business since 1997, so over 25 years now. We believe in a world that can make the switch to a sustainable future without sacrificing safety. And that's why our premier product, F500 EA, that's what it's best at, is saving lives, making people safer, making businesses and industries safer without sacrificing uh, the environment, the sustainability and quality of our environment, which we all have to enjoy together. So, and we're going to plan on showing you today how F500 actually is an environmental benefit over plain water use, and definitely over a lot of other agents that are in use these days. We are specialists in the control of modern day combustible and fire hazards. There are a lot of new and emerging materials on the market and in use worldwide. And since our agent is a water additive, it's scalable to any solution, but we're gonna explain why it's unique in a few ways as compared to some of the other agents that are available, especially plain water. We are the inventors of a fire control and vapor mitigation agent called F500 encapsulator agent. We're also going to explain to you what an encapsulator agent is and how it falls into the regulatory and standards that are in existence today. So our agenda today, we're going to talk about first the various risks associated with contemporary industrial fires and the fire setting, what's changing in that environment, and how F500 is the perfect agent to use on those fires. And then how NFPA recognizes encapsulator agents within the NFPA structure, as well as some other worldwide standards. So there's an alarming trend of lithium-ion batteries showing up in waste streams, intentionally or unintentionally. They're getting in the waste stream and causing fires in recycling centers, as well as other environments. Recycling centers is something that's present worldwide and a worldwide concern. Those fires have been on the increase in the last several years as more and more lithium-ion batteries find their way in the waste stream. They're one of the key causes of unintended fires at recycling centers. There are other causes as well, and you should look into those causes, but no matter what the cause is, we're we're going to show you why our agent is uh, a great choice for controlling these fires, keeping them small, protecting workers, the public, and firefighters at recycling facilities. As power grids age and their vulnerability to attack is more evident than ever, substations and electric power plants as a whole demand better protection. So most of these, by and large, are relatively unprotected now and subject to open air, open elements, subject to and vulnerable to attack by lone wolf attackers, and depending on where you're from, and really all of us, we're all vulnerable to attack by our enemies. Unfortunately, we don't live in a totally peaceful world. We have to recognize that and protect our infrastructure from attack. But our infrastructure is also aging. So a lot of the transformers are 40 plus years old that are in service today, and they're hard to obtain replacements. So we need to put extra emphasis on protection of our current infrastructure and make sure that we're keeping that healthy. If you look at the picture, you'll notice that not only are there some current transformers in the background, but there's a lot of metal infrastructure just supporting the cables, the heavy transformers, etc., at power plants, primary generating stations, substations, etc. So F500 not only helps protect transformers and critical infrastructure that helps generate the power, but also the supporting infrastructure. F500 can help keep that cool and make it so that you're just sliding in a replacement unit potentially rather than replacing the entire structure. Parking garages, they're now threatened by battery electric vehicles, hybrid electric vehicles, and they've always been threatened by internal combustion engine vehicle fires. Now there's much more of a mixture of those vehicles, and as time goes forward, and as many governments are mandating, there are going to be more and more battery electric vehicles and hybrid electric vehicles filling those parking garages. Parking garages are typically attached to critical infrastructure like hospitals, airports, office buildings, and they're centrally located in high density population areas where their loss would create a big impact. Their parking garages are receiving increased regulation across the board from code enforcement agencies. For example, insurance companies are putting more and more regulation on providing sprinkler systems and deluge systems inside of parking structures, which for the most part, at least where I live, are unprotected by any sprinkler systems because they're subject to freezing. So now insurance companies and also NFPA is requiring that all parking structures are protected by sprinkler systems. But we're going to look at a little bit of a couple parking structures later on in the presentation that actually collapsed due to vehicle fires, multi-vehicle fires. And the unique thing about those is they were not battery electric vehicles. They were both internal combustion engine vehicle fires that initiated them, but they turned into multi-vehicle fires very, very quickly. We just have a more intense focal fire when we're talking about battery electric vehicles and hybrid electric vehicles, and then their ability to catch multiple vehicles on fire. There's a fire today, you may have seen it on LinkedIn, where there were 30 plus vehicles involved in a single fire because of a battery electric vehicle being out of control. Petrochemical, oil and gas industries, they're seeking solutions to flammable liquid and vapor hazards that don't contain PFAS. PFAS is a big problem environmentally as well as for human health and firefighter health. So the petrochemical industry really needs a better solution than the PFAS foams have ever been able to offer. So the solution needs to perform really at a higher level than ever. And we definitely don't need to take a step back like some of the fluorine-free agents that are on the market now present a situation where they'll work, but they don't perform as well as the PFAS containing foams did. We're going to show you that there's an agent, our agent, that performs at a much higher level than foam ever did. So the need for adequate fire protection in the aerospace industry, the aviation industry, that setting has never been more crucial. The industry leaders are looking again for a fluorine-free alternative with multi-class abilities because you're not only dealing with combustible liquids, you're dealing with combustible metals, rubber tires, and really we're dealing with life. When you're talking about a hangar situation or an aircraft situation, we need a life-saving water additive, not one that only puts the fire out over, several minutes, several hours to bring a fire under control is not acceptable if we're going to save life. And that's our goal, is to save life. So there are many industries that benefit from F500 encapsulator agent currently, and many industries that will as regulations change, as PFAS goes away, and as our threat profile changes. So let's listed a few of them here. The energy infrastructure and energy storage industries. Battery energy storage is becoming a big thing on the grid as a peak shaving method and also a way to balance load over a 24-hour period and provide some surge capacity when maybe it gets really hot or really cold so that we can keep up with heating and air systems, for example. The recycling industry, whether it's plastics, paper, municipal waste, or if we're talking about automotive recycling, those industries are current beneficiaries of F500 encapsulator agent proportioned into their sprinkler and deluge systems, but there are many out there that haven't protected their facilities yet and need to do something about it. And we're going to show you in a little bit how F500 can meet that need. Combustible dust producing industries. Pretty much a worldwide thing. When you make products, you also make a mess at the same time, and combustible dust is one of the byproducts of many manufacturing processes. Paper, wood product manufacturers, pulp, things that need water additives to help water better soak into their products to put fires out more quickly and control fires more quickly. Flammable liquids refining, transport, and end users all need methods to suppress fires in their particular situations. The battery electric vehicle and hybrid electric vehicle manufacturers, fleet operators, shippers, and even dealers and automotive repair shops need solutions for their sprinkler systems. The truth is many of these facilities are either unprotected or definitely unprotected when they're unoccupied. We can't always rely on manual fire extinguishers being the solution, especially when the facility is unoccupied or there are a lot of robotics included in some of these processes. The robot's probably not going to pick up a fire extinguisher and use it. So we need to have automatic protection built into those situations. Parking structure operators, battery manufacturers and recyclers and warehousing of those batteries. There was a warehouse facility in California this past week that stored lithium-ion batteries that suffered a multi-day reigniting fire that I don't know particularly, but I know it was, if it had a sprinkler system, it was plain water. Um, Tire and rubber industries, tire warehouses, the aerospace industry, automotive manufacturing industry. There's a lot of different facets to that, you don't think about all the time. Like, I know vehicle automotive industry companies that strictly make automotive seats and seat frames, and then they're a supplier to the automotive factories themselves. So there's a lot of supporting industry out in the world that uh, is not an automotive manufacturing assembly plant, but still does automotive work. And those plants all need to be protected as well. Combustible metals producing industries, there are many of those which we protect, but there are many more to protect. And then anyone needing a PFAS alternative is a definite candidate for F500 in a suppression system. So this video I'm going to show next was at a Pepsi production and distribution plant in New Jersey in 2022. That fire is still being investigated. The initial reports indicated that multiple propane tanks exploded, which contributed to the fire's size. The fire began in the back of the building where wooden pallets were also stored. So in most of these fires, you don't only have one class of fuel involved, you have many classes of fuel. And it could be wood products like the pallets at this Pepsi plant. It could be any of the supporting industries. And another thing that we're seeing a lot of is material handling equipment now is being converted to lithium-ion battery power away from lead acid batteries. We'll go ahead and play the video.
The huge flames erupting at a Pepsi-Cola factory.
Only Newscopter 7 has pictures like this, the fire in the Middlesex County township of Piscataway.
Eyewitness reporter Josh Einiger live at the scene with new information we just got moments ago from the mayor. Josh.
Yeah, Bill, things have finally calmed down here at this PepsiCo bottling facility behind me, but wow, it was a different story over the last several hours. We can go back to that video from Newscopter 7 as it was fully engulfed. This started just before 7 o'clock this evening. Township officials tell me that the flames started on the outside of the building, climbed up one of the walls.
So something that was just stated there, the flames began on the outside of the building. Sprinkler systems don't typically cover the outside of a building. So alternative sprinkler systems could, but firefighters have to get involved in that as well. And you'll notice that as they were battling that fire, it was a deep-seated fire, probably in the area where they may have had hundreds to thousands of pallets stacked. So those deep-seated fires are a problem for firefighters and for fire suppression systems. And that's one thing where F500 really, really excels at, not only putting the fire out faster, but controlling visibility, smoke levels, smoke emissions for public safety, community-wide, and for protecting egress.
And then infiltrated the roof, and at that point it was game on for this all-volunteer fire department here in Piscataway Township who arrived and found this inferno in progress, a firefight that quickly climbed to 5 alarms.
When you're arriving on scene, you saw a fully involved fire. You're saying, all right, what's going on here? Once they determined that there was nothing that was going to put the fire volunteers in harm's way, they repositioned the 4 ladder towers that are pouring water on right now, and they're going to continue pouring water through the night on this structure.
It was like a good 7 to 8 loud noises. So I was like, what's going on? I seen all this fire, all this explosion and everything, all this smoke coming from the sky. It was like pretty amazing to me. I've never seen that much black smoke, thick smoke in the sky and everything like that.
And back live here, they continue to pour water on what's left of the smoldering embers in that big factory there. This is one of PepsiCo's largest bottling facilities in the tri-state area. The state and county fire marshals are on scene trying to figure out what caused all of this. The good news that of the dozens, maybe as many as 100 employees inside there, not one person was hurt. They all evacuated safely. 2 volunteer firefighters suffered minor injuries tonight. We're live.
The huge flames erupting.
So the next video I'm going to show is from a fire on March 16th of 2022. It's at the Plainfield, Indiana Walmart Distribution Center. It was a 1.2 million square foot facility. Everybody saw it. I'm sure everybody on our presentation today has seen this before. But if you think about the airborne emissions that came off of this fire, as well as the fire runoff, they were extreme. So that airborne emissions from a large fire like this one was visible by satellite, those things all go somewhere. Just like radioactive fallout all goes somewhere, these products don't disappear. They land on playground equipment, car door handles, homes, yards, pastures that our ruminant animals and dairy cattle eat off of. So it all goes somewhere. It all has an impact. The runoff water impacts the environment, the fish, the rivers, etc. So I'll go ahead and play this video. This one doesn't appear to have any sound, which is fine. But if you pay close attention to the airborne emissions, if this fire had been brought under control quickly, and I know there was some issues with the sprinkler system potentially having been turned off a little bit too early to check for extension of fire, which is a factor no matter what. When you use an agent like F500, it controls the emissions, puts the fire out faster. It soaks into paper, cardboard products much more readily than plain water. It's able to penetrate through canopy fuels, etc. And it's multi-class fuel applicable. You don't have to worry about its compatibility with one fuel and not another, or in one situation and not another. It's multi-class, multi-situation water additive. The fact that it's a water additive makes it scalable to any incident from the smallest to the largest. So mitigating risks with encapsulator agent. We'll talk a little bit here about what an encapsulator agent is, what it means to be an encapsulator agent, what differentiates an encapsulator agent from foam. An encapsulator agent is not foam. It's got some unique qualities and capabilities that make it also much better agent than dry chemicals, dry powders, and other agents as well. So we'll talk about what an encapsulator agent is to begin with. So an encapsulator agent is defined as a type of water additive whose basic building blocks are called spherical micelles. Those spherical micelles are capable of encapsulating carbon and hydrocarbon molecules from both polar and nonpolar flammable liquids and vapors. It separates the fuel from the oxygen on a molecular level. And they're covered under the relatively new standard called NFPA 18A. This next video is going to show you what happens to an F500 molecule as it enters the water stream and how those molecules collectively turn into spherical micelles and impact the structure of a water droplet.
Encapsulator technology. The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So if you look at the structure of that water droplet, if you look at the blue part, that's representing the outside layer of a water droplet. Inside of the water droplet, it's packed with millions and millions of spherical micelles. Those look like little golf balls there, and there may be, 40 or 50 of them there in the picture, but in reality, there's millions and millions of them. They're very, very microscopic. And those pack the water droplet throughout and absorb heat very, very readily from the outside of the water droplet to the inside. Now, the skin of the water droplet is lined with F500 molecules pointing the other way. So the polar head is attracted to the water, the nonpolar tail is pointing away from the water and gathering in heat, grabbing onto more carbons and hydrocarbons, and together, those things protect the water droplet from extreme heat, help to absorb heat into the center of the water droplet, and then the carbons and hydrocarbons are stuck and trapped inside the spherical micelle, or what we call locked up. They're locked away from oxidation, the oxidation which would allow combustion. So once those carbons and hydrocarbons are trapped in there, combustion ceases. It's not able to happen anymore. So if we look at this on a broad spectrum application, we're absorbing a lot of heat. We're absorbing carbons and hydrocarbons not only out of liquid fuels, but also out of the air immediately above the fuel in the vapor space. It's also got a high molecular weight. So it does another thing called the interruption of the coalescence of free radicals. So when we have incomplete combustion here on Earth's surface, free radicals are produced, and that's what was coming out of the Plainfield, Indiana Walmart distribution center fire there. That smoke, the soot, the toxic compounds and gases, they're all emanating from that fire. F500 blocks that reaction from occurring, so you don't have the production of that smoke in the first place. And if the smoke is already being produced, it cools the fire very quickly, blocks the production of additional smoke and soot, and clears up the atmosphere very, very quickly for people to escape the fire, as well as firefighters to find people trapped in the fire. So some of the mechanics of the agent include that it's one agent for all application. It really is an all hazards water additive. It's very versatile, broad spectrum. The effects and impacts are all positive. There's no negative impacts. Since it is a water additive, it's very easily scalable from the smallest to the largest incidents by simply proportioning them the agent into a sprinkler or a deluge system. As water flows, so does the F500. And the nice thing about that, the facility where the sprinklers are at can be attended or unattended. It's protected either way. You can use it as manual suppression in extinguishers as well. As we move towards a net zero goal for industrial applications as well as industrial incidents like fires and spills and so forth, F500 enables that. So testing shows that F500 is an environmental benefit when compared to plain water. Why do I say that? Because it interrupts those airborne emissions from being produced as the F500 is being applied, and then fire water runoff is automatically treated by the existence of F500 in the firefighting water, and it encapsulates those compounds in the fire water runoff as well, and makes that runoff much more friendly for the environment than water would. Plain water would just dilute those compounds, wash them away, wash them down the stream, where they would end up in sewage treatment plants, rivers, static bodies of water this way. With the F500 in there, we're encapsulating those harmful compounds before they ever reach those facilities. So this testing occurred as a result of um, the need for a power company to better protect their under turbine lube oil system and protect their turbine itself. So the lube oil system protects the turbine when they leak, they tend to catch on fire. So Dominion did some sprinkler testing because their insurer wanted them to go up to a higher sprinkler density. Basically wanted to double their sprinkler density from a 0.20 to a 0.40. And they were going to have to do that if they couldn't prove another method to do that. So they elected to test with F500, and I'll show you the results of the test in the video. So again, this test compared plain water at 0.40 gallons per minute per square foot sprinkler density with F500 3% concentration at a 0.20 gallon per minute per square foot sprinkler density. So half the sprinkler density. 0.20 was also the previously existing sprinkler density of their under turbine lube oil system. Now, this test included a pre-burn time to allow the burning product to reach 1100 to 1300 degrees Fahrenheit. So it got plenty hot, heated up the steel, etc., associated with the fire so that it was reality based. What you're going to notice here is that the F500 fire on the left side goes out much quicker. The air is cleaned up much more quickly. It cools the steel and surrounding objects much more quickly. And the fire was extinguished in 11 seconds. Now, this was considered a full-scale test. It allowed Dominion, or excuse me, Con Edison, no, Dominion in this case, excuse me, got my power companies mixed up. Dominion to keep their existing sprinkler system, to not have to put millions of dollars into it. And because they were able to do that and incorporate or proportion F500 into that sprinkler system, they were able to save a lot of money, put fires out quickly. And the end result was that with F500, the fire was extinguished 3 times faster at half the sprinkler density of plain water. So let's talk about proportioning. We have a few different ways we can proportion. The first one we'll talk about bladder tanks. So although they're a little bit more complex and expensive to keep up than their modern counterparts, bladder tank systems have been around for a long time. They're very reliable and very robust. However, they are more complicated, and the total cost of ownership is somewhat higher than the other option, which we'll talk about here in a second. Now, our bladder tank systems that we provide and we commission and we engineer are typically used to protect a finite fire load, something like a machine or a process area, something like a dust collector, where we know we can overcome that fire situation because of its relatively limited size very quickly and with a finite amount of solution. System benefits behind a bladder tank system are that even though it may be limited to a certain quantity, because it's much more effective at cooling and extinguishing than plain water, we can put that fire out with quite a bit less overall solution than plain water. It's a concentrated deployment and lower upfront cost typically. However, I sent a proposal out yesterday, a comparative proposal between a bladder tank system and our other system, which is called a diamond doser, which we'll look at in a second. And the bladder tank system actually came out to be more expensive. So our newer option, and one that's finding a lot of favor in the industry because of its robustness, it's the really the volume range of it is terrific, and the fact that it has a lower total cost of ownership is called the Diamond Doser. It's a volumetric water-driven proportioner. It's a simple solution, very simple plumbing, which we'll show you an example of in a moment. Um, uh, it The neat thing about it is if water flows, so does F500. It drives a water motor, and the water motor drives a small piston pump or a gear pump, depending on the viscosity of the agent it's pumping. And that agent is correctly proportioned into the sprinkler riser just based on the rate of turning. Very, very simple, very robust. Requires no external energy source. So it doesn't matter if the building's got electricity or anything like that. If water's flowing, so is F500. The nice thing about it, it's not a finite, quantity. They're really the only limitation on duration of application is the limitation of the storage tank for the concentrated agent itself. So the agent storage tank can be as big as you want it. You could even have reserve that you can plug into it and keep operating. So some of the system benefits: expansive protection, effortless integration, very simple system, convenient testing. So when you test this, you don't have to expel agent on the ground, for example, and cause a cleanup problem or a disposal problem. You can simply turn a valve and the agent goes back into the concentrate tank as you're expelling water out, but it tests both sides of the system, the water motor and the concentrate pump. The concentrate's just put back into the tank rather than put into the stream during a test mode. So there's zero waste. There's a lot of benefits to this system, and one of them is just the wide-ranging volume that's available. This little video shows you how the system is put together, how it works. So this is the water motor part of it. As water goes through the riser, it turns the water motor. That spins a shaft. Beyond where you can see, it's driving a small pump. The agent is then proportioned into the riser at the correct rate, simply based on the rate of RPM of the pump. And the pump is sized to meet the riser requirements, up to 10,000 liters per minute. And if we need to go over that, we just put them in tandem. So proportioning, the smallest Diamond Doser unit is 48 gallons per minute or 180 liters per minute. And the largest unit is 2,600 gallons per minute or 10,000 liters per minute. And that's with 3% proportioning fixed. You can have fixed rates of 1 or 3%. We do have portable models available with selectable proportioning, and you can use viscosities. It doesn't have to be F500. You can use Newtonian, non-Newtonian liquids with a viscosity of up to 8,000 centipoids. So for higher application rates, we can actually, as the picture shows, put them in tandem. So we can basically double or quadruple, whatever it takes to get up to the right rate of proportioning based on the volume requirements. We do have in-house engineering support. So if you have a fire protection system that you need us to help you design and supply, we can use our in-house engineering support team, jumps on board with you to help create a proposal, provide complete proposal and drawings, and then once the system is installed, we provide the commissioning to put that system in service. So some of the companies that use our systems now, AP&C, for example, uses two 600-gallon bladder tanks powered by F500 protect titanium storage. I'm going to go through a few of these here, just examples of companies that use our proportioning systems already with F500. Con Edison, F500 was successfully used in New York City to extinguish a fire in a ground transformer, a large ground transformer. Um, Con Edison caught wind of that and decided, well, we need to do some more testing with this F500 stuff. So they put together a test to determine standoff distances. So they tested the F500 on a large power, high power circuit up to 345,000 volts to establish appropriate standoff distances. However, and that's for manual firefighting, but F500 is extremely effective at extinguishing large power transformers and the three-dimensional fires that they have as a major characteristic because of the cooling oil. Um, uh, it's a thing that foam is not very capable of, that three-dimensional fire, because it's hard to put a blanket on a moving object, a spraying object, etc. Plus, the foam has a tendency to hold the heat in. And when you're talking about a transformer fire, hot oil, hot steel, all of that stuff in combination, you need an agent that cools really, really well, and F500 does that. Embraer has a bladder tank to protect their warehouse. They have rack storage of a lot of volatile products that go into making an airplane, and they wanted better fire protection, and F500 does that for them. General Motor uses bladder tanks to protect their lithium-ion battery abuse lab. We're going to talk a little bit more specific about lithium-ion batteries here in a moment, and how F500 can be used to protect parking structures. Goodyear uses a 4,000-gallon bladder tank to protect a tire storage warehouse in Memphis, Tennessee. We have some other ones around the world as well. Kiewit uses two 2,700-gallon tanks and two 2,100-gallon tanks and two 1,400-gallon bladder tanks, all with F500 to protect their LNG plant in Maryland. And then lastly, Tesla uses 7 water-driven proportioners, which you can see in this little top. Oops, I bumped it and made that slide go away. In this top right picture, those are the water-driven proportioners that protect the Tesla Gigafactory in Sparks, Nevada, and the Tesla Panasonic factory in Reno. These are all companies that use F500 in their sprinkler systems and deluge systems every day. We've got a number of them around the world. This is a very small accounting of them and manifest of them, that with companies that you may recognize their symbology. We have many, many more that we can provide as a reference as needed. So the kind of the last thing I want to cover is a kind of our latest application of F500 that really is on the cutting edge and meeting the cutting edge technological advances in the world of public transportation. So a company in Spain called Applus, they're kind of like some other companies around the world that do third-party testing for safety, fire protection, etc. So Applus took on a project to test parking structure fire protection using F500. It should be noted, kind of a predecessor to this testing, that FM Global in 2021 increased the hazard class for all parking structures from a hazard class 2 to hazard class 3. And likewise, NFPA increased the recommended hazard rating for parking structures from a group 1 hazard to a group 2, kind of in line with one another. And then in 2023, NFPA required all parking structures to have sprinkler systems installed with in accordance with NFPA 13. So there was, from now on, from 2023 on, there's not a way around sprinklering your parking structure. And it should, a couple of quick case studies here. Stavanger Airport had a partial parking structure collapse in 2021. There were 200 to 300 vehicles destroyed, 1,300 vehicles damaged. Um, uh, this and the next one, however, were both started by non-EVs, but became to involve EVs and all the vehicles. So you really have to look at the um, the abundance of different types of vehicles and materials involved in vehicle construction now, and energy sources as well. So you can have uh, internal combustion engines, petroleum products. You can have lithium-ion batteries. You can have CNG vehicles. You can have combustible metals involved in these vehicles as well. Um, but the real problem is when multiple vehicles get going in the same area, they can quickly compromise the structural stability of a parking structure. And as more and more battery electric vehicles occupy parking structures, the weight goes way up because they're heavier. So that toxic smoke and soot also creates a very unsafe environment for anyone that's currently occupying or trying to escape that structure. With lithium-ion batteries are involved, those gases are so toxic they can take down a person very, very quickly. The next one I'll talk about is the Luton Airport fire in the UK in 2023. This involved also a partial collapse of the parking structure. 1,500 vehicles were destroyed and 1,300 damaged. Again, was not an EV that started it. It was a diesel vehicle. But it quickly took over the entire structure. The airport had to shut down for a while. If you look at the effects of fire on concrete, post-stressed or pre-stressed, about 200 degrees Celsius starts spalling deterioration of the concrete. And when you're talking about electric vehicle and the blowtorch effect flames, they can focus all of that energy on a support column, for example, or something of that nature. And then when you get multiple vehicles involved, you can get those temperatures up there very, very quickly. Steel beams, even the rods and the cables in pre-stress and post-stress concrete can become weak as the concrete becomes weaker and begins to spall. That entire structure gets weaker. This video I'm going to show is of the Luton Airport. You can see that the fire broke out from one area into another one very, very quickly once it got going. This is a partial collapse of the structure. You can see early in the video from that previous angle was vehicles falling in. This is the other angle from the top, vehicles falling down into the structure as the concrete got weakened. One of the things found in this fire was that the stormwater runoff system became a liquid fuel runoff system once the tanks began leaking. So it channeled the liquid combustibles down through the structure. So this video shows how fire protection in a modern parking structure was tested by A+. It shows the specific test I mentioned earlier involving two vehicles in a 3-space wide parking structure space. So this space was mocked up in a tunnel. They have a test tunnel for fires at A+ in Spain. And this test was mocked up with a lowered ceiling to mimic a parking structure, to mock up a parking structure. It had a grid system of Deluge sprinkler heads over the vehicles. One space was particularly left empty as an egress pathway for someone who would otherwise be occupying the structure. You'll see the vehicle in the black vehicle in the center parking area had a 50 kilowatt hour battery placed underneath it as to mock up an EV battery. And then next to it was a typical or legacy vehicle with an internal combustion engine and a gas tank. So they let a pre-burn time. They let the fire get going very, very well, let it get really hot, well into thermal runaway. And then they kicked on the deluge system. The deluge system involved several heads with F500. So they let it get fully involved, and you see it's impacting that vehicle next to it. The sprinklers have not started yet, starting to melt the mirror on the side of the car, melt the paint. The vehicle of origin is well involved. Now suppression was kicked on manually. And you'll see it controls the fire. You've got some material ejection coming out of the lithium-ion battery there, which is somewhat common. You'll notice the smoke is very well controlled. And that was one of the findings with the test, is that it enabled public escape or egress. And that's one of the features of F500 that it, it it's kind of one that gets probably talked about the least, and that's the encapsulation of gases, the clearing up of the atmosphere, enabling public escape and egress, worker escape and egress, if you're talking about a workplace facility. Um, so it's very, very powerful at saving lives. Oops, I'm sorry, I accidentally reset the video trying to get to a specific spot. So the agent was proportioned into the sprinkler risers with a diamond doser, water-driven proportioner. The detection system was installed. The detection's kind of its own animal when it comes to lithium-ion batteries. One of the big problems with the lithium-ion battery is that they can produce a lot of gas before they ever produce fire. They can actually become explosive. So you have to think about that factor as well. A total of 6 FM approved nozzles in this scenario were used, 2 per parking space, and they discharged at a 95-degree angle. As far as water supply goes, 3,800 gallons were used in the overall test, or 14,000 liters. However, the fire was successfully contained way before that. It was successfully contained in only 4.5 minutes, using only 297 gallons of water, or 1,125 liters of water. So it was contained very, very quickly. They let it run for, I believe, around 45 minutes. That's why they overall used as many gallons as they did. It contained it throughout. And we're going to show you some pictures here momentarily of the end results of the vehicles. So this diamond doser, the diamond doser 450, operated at a minimum flow rate of 20 gallons per minute, or 76 liters per minute, and a maximum flow rate of 450 liters per minute, which is indicative of its model number, or 119 gallons per minute. And although a 450 liter reserve of F500 concentrate was supplied to meet the test parameters, only 9 gallons or 34 liters of concentrate was used before achieving containment of the fire. So it doesn't take a lot to achieve containment of most fires, although you do want an adequate reserve. One of the reasons for an adequate reserve is in a lot of cases with F500 in industrial settings, you can mop up and get back to business fairly quickly because the damage was kept so low. So if you look at the some of the pictures we have here, some of them are a little bit on the smaller side. And although copious amounts of water in F500 was supplied, again, the fire was contained in just 4.5 minutes, using only under 300 gallons of water and under 9 gallons of concentrate. Limited damage to the adjacent vehicle. So if you look at the bigger picture, you'll see the mirror and the paint damage on the adjacent vehicle, but it never did catch fire. So it was kept to the vehicle of origin. Egress possibility was maintained throughout. So it was really a very successful test. So here's the kind of the coup de grace, the grand finale, if you want to call it that. Because of that testing, the mass transit system in Madrid, Spain, was able to use that testing to enable them to go ahead and install an engineered system to protect their new mass transit bus facility. So this little video is going to show you a little bit about that facility. Right there, you can see the individualized charging stations, and the fire protection is built into those charging stations as well as the general sprinkler system. And this is an ultra modern facility. A lot of it is at least supplemented by solar energy to help keep it less of a drain on the electrical grid in Madrid, Spain. Also, because those shoes came down on the top of the bus, it reminded me that when you are dealing with a bus situation, in a lot of cases, those batteries are located on the roof. So this facility just opened a couple of months ago. It showcases how F500 encapsulator technology is really on the cutting edge of innovation and sustainable innovation as we move forward in a battery-enabled world. This is kind of a video showing the test in the test tunnel itself. and the concept that it provides also for parking structures. Now, that was upscaled for the buses, but this is how it might be used on a typical passenger car facility. But before I end, I do want to point out that when it comes to lithium-ion batteries, F500 is cited in NFPA 18A Annex 4.3 as being highly effective on lithium-ion batteries. Our testing with lithium-ion batteries has gone on since 2008, longer than any other suppression agent in the world. And the reason it's gone on longer than any other suppression agent in the world is because it's very, very successful. We've never had a failure in any of the testing by many third-party agencies and universities from around the world. And that's why the testing continues. If it would have been a failure after one or two, they would have stopped testing it. But it hasn't been a failure. It's been highly effective. And because it's a water additive, it's highly scalable to any situation. So that's pretty much the end of the information in the presentation. I'm going to go ahead and jump out of the slideshow. This is how you get a hold of us, however, before I jumped out of the slideshow, and that's our number and our website. We have request forms on the website for additional information as well. But I'm going to jump out of the slideshow so maybe we can address some questions. I can get my screen to pop back up. There we go. All right, let's look at the chat here. Are you still with us, Heather?
Yes, absolutely.
Okay. Can you go through some of the questions for me that I may have not seen in the chat here, or that you have seen?
Sure.
Or at least get me on the right track where I'm supposed to look, where the first
There's a
question might be.
Q&A section as well on the bottom. You'll see like two chat bubbles.
Okay, Q&A. I was looking in the chat. I see it now. I got it open. All right. How is this foam designed for fire sprinkler systems? Okay, so first off, F500 is not foam. It's a water additive agent. It's an encapsulator agent. It's definitely not foam. Does not work on the principle of bubbles at all. But it is A and B listed under UL, can be proportioned into riser systems very, very simply as we showed in the presentation. It I would say it's got a consistency of a lightweight oil as far as its ability to be proportioned. So, and then because of the amphipathic molecule, it 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 self-dilutes more or less. If you want to put it in those terms, it readily mixes with the water. You don't have to agitate it or anything like that. As soon as you proportion it in there, it's going to be coming out of the sprinkler heads very, very quickly. Um, I'm hoping that answers your question, Kevin. I'm not sure if it does or not. I noticed you also asked the second question, is the Diamond Doser UL or FM approved? They've done testing for FM approval. They're waiting for documentation of that. They were FM approved, then they made somewhat of a design change to make them uh, to address uh, an issue of longevity, and so they had to go undergo FM approval again. So that being a somewhat of a lengthy process, um, they're waiting on some paperwork, but there are several models that have been FM tested, and we're waiting for the approval paperwork from FM. I see another question here in the regular chat. Um, uh, has F500 been utilized for helicopter pads on top level structures in lieu of foam and water suppression systems? Uh, yes, let's see. Let's see, is Mike Reiner on here? Okay. Um, Heather, do you know if Mike's on?
I don't believe so. He's currently in a
Okay.
meeting.
We do have some systems that are manufactured by a third party that use F500 specifically for helicopter pads. And I'm trying to remember the name of them right off the bat, and I can't. Uh, so that one we'll get that information to you as soon as possible, and we'll respond directly to you on that. Um, I'm gonna look through the chat for other. The nice thing about F500 and the flammable and combustible liquids involved in uh, like Jet A, for example, for helicopters, the knockdown time is extremely, extremely fast compared to a foam because we're not having to cover it with a blanket. And it can be very windy up there on top of buildings, and it's not, other than the stream hitting it, it's not dependent on a blanket that has to be stable in the wind. It interacts with that fuel and puts it out very, very quickly, within seconds typically, with a sweeping pattern. So it works very, very effectively in those types of situations. I'm going to look down through some of these others in the chat to make sure we don't have any questions in the chat that I'm missing before I go back to the Q&A side. Okay, back to the Q&A side is here. Roberto asked, what's the latest approval of FAA for use of F500? So F500 was included in an FAA circular in 2023 under the other category. So it can be used for really any use on airports. Uh, However, it's covered under the other category, and they mention it for use on things like lithium-ion batteries, other hazards, but it's applicable to all hazards. And we were actually present at the FAA's ARF Leadership Conference in Florida a few months ago, and gave a presentation on how it can work to save lives in a fuselage of an aircraft that would be on fire, ground spills, lithium-ion batteries in parking structures. There's more than one airline company now that's advertising that they're switching to EV-powered ground support equipment as a part of their efforts to could create a more sustainable environment. And that brings up an interesting conundrum: is are they able to put those out? And the answer is, without F500, probably not. If they're going to use plain water, it's going to take thousands and thousands of gallons of it. We're talking probably up to 100 kilowatt hour battery and in many of those pieces of ground support equipment, if not larger. Foam will also not put them out. It just holds the heat in. F500 puts it out readily and controls the environment around it as well. So it's a good all-around agent for use on airport property, whether it's a handheld extinguisher in the airport or in aircraft for personal devices, or small fire apparatus going into the parking structures, or for ground support equipment, or even for aircraft. It works very, very quickly. And uh, there are some limitations in performance of fluorine-free foam. And those are going to come to the surface, if they haven't already, as a problem area that has to be overcome. F500 is one way you can overcome that. Okay, Michael Shea asks, what happens to the toxic gases and hydrocarbons after they've been contained in an EV fire after the F500 EA breaks down? How long does it take to break down? So that's a very good question. So when carbons and hydrocarbons are encapsulated by F500, it does break the hydrocarbon chains. And they're encapsulated inside of spherical micelles, which are over 100,000 times smaller than the microbes in soil. So if the product is washed into soil, for example, microbes eat it up. It's biodegraded into the soil. Same with surface water, although there are some issues with surface water and EPA permitting for that and so forth, it'll still biodegrade in water because of microbial activity. As far as stuff that lays on pavement, gets hit by the sun and wind, and evaporates over hours and hours, um, what's evaporating is broken hydrocarbon chains. It's no longer in its native form and no longer as harmful. So, and it really breaks down in a very environmentally friendly way. The Hopefully that answers your question, Michael. We've got 25 years of environmental testing and test reports that we can share with anybody. And it also meets, I believe it's section 5 of NFPA 18A, which covers the environmental requirements to meet NFPA 18A, and it does meet those requirements. Doug Delabro asks the question, would you be able to get a lower density approved with F500 for a project that is lithium ion vehicle storage? Is there a code reference? First off, I guess I would want to know why you would want to get a lower density, a lower sprinkler density approved. I think right now our full scale test is at the same test, the A+ testing. If we wanted to do, or if someone wanted to use a lower sprinkler density, then we would have to prove that. So typically we don't advise people to use a lower sprinkler density than plain water. And the reason for that is because if some kind of mechanical proportioning device doesn't work for some reason, you're still getting plain water to at least control the fire. With F500, it just puts it out a lot faster and controls the environment for egress and for firefighter ingress. However, any lower sprinkler density typically has to be approved by a full-scale test. And that comes with some expenses, everyone knows. So, but we're willing to participate in those types of tests. I would reach out specifically, Doug, and pose that question via our website form and get in touch with us, and we'll work through that process. All right, question from Alan. Is HCT actively working with ICAO to get F500 EA approved for other regional CAA-controlled airports outside of the U.S.? And that answer is yes. We've written letters to them. I know it's somewhere in the process. If Mike Reiner, the president, was on, he could probably answer very specifically that because he's the one that writes the letters and gets the responses. But we are working with the ICAO for that purpose to get it approved worldwide, as well as FAA and other organizations, even military, etc. We are working through that process. So I hope that answers your question there. Unfortunately, we're not able to move as quickly as we would like to in some of those regards because some of these agencies and organizations don't meet every day and don't answer those kinds of questions and concerns every day. We we definitely are always working on all of those fronts to move forward as quickly as we possibly can in participation with those agencies, however. All right, do we have any more questions? Anybody out there have any other questions today? Looks like we had about 40 plus people on today. That's great. I really do appreciate your time. We all do, about learning more about F500. We have an abundance of information to share. If you look at our website and you look at our e-library, you'll see all of the different classes of fire are addressed in our e-library. And then we have special sections on lithium-ion batteries, for example. Oops, I do have a new question. Paul asks, aside from NFPA 18A section 4.3, which encourages the use of F500 for use on lithium-ion fires, is there an NFPA standard for lithium-ion fires? Very, very good question. NFPA sets the classes of fire here in the US, at least, A, B, C, D, and then K for kitchen fires. They have not separated a class for lithium-ion battery fires as of yet. You know, there's some from what we're told from some of our people that participate on NFPA committees is they consider lithium-ion batteries a Class C fire because it's an energized electrical circuit, because there are stored energy in lithium-ion batteries. So you could make the argument both ways that that's correct. You could also make the argument that they're unique enough that they deserve their own class, which stands to reason. They probably do. And it would be easier to define the right agent or agents to go with that class if they did separate it. However, they've not done that, at least yet. We just know through testing since 2008 that F500 works very effectively on lithium-ion batteries. And although it's somewhat, lithium-ion batteries are used in everything from e-cigarettes to heavy equipment, battery energy storage systems. Whenever F500 has been applied at the appropriate rate, they've gone out very, very quickly, used very little water in doing so, created less runoff, a lot less runoff than plain water or other agents, and mitigated the runoff water to a point where it's a lot less expensive when it comes to cleanup. Plain water, foam, and other agents can create a lot more expensive cleanup than you would have with an F500 because we're mitigating the runoff as we're applying it. So great question, though. Again, we really appreciate your time today. If you would like more information, be sure and reach out, fill out our contact form. We'll put you in touch with someone individually to answer your question, hopefully help you with your upcoming projects. And we're always happy to help, excited to get involved. we're excited about new challenges each and every day because you're all out there developing technological, innovative solutions for the world, and we want to help. We want to help keep it safe. So appreciate your time. Thank you, Heather, and we will go ahead and sign off.
Thank you, Dan, and thank you for everyone in attendance. We appreciate you.
Have a good day, everyone. I'll let you close it, Heather.